Okay, so I want to go through some of the practice questions here. Just gotta, just again, kind of thinking through like how would I graph these, and sometimes seeing, the thought process and working out a couple of them together is going to help when you see them on your own. So the first one I see is 3 to the negative x minus 1. Okay, so I know there's two transformations, right? I know that there's the negative x as an exponent. That's going to be a reflection over the y-axis. And then I also know that this minus 1 is going to shift everything down 1 unit. So sometimes what I like to do with that minus 1, again, is I would just almost like draw a pseudo x-axis, like that's down 1 unit, because I know that everything had been pushed down 1 because of that. So that's my x-axis, that's my y-axis. So this line is like y equals negative 1. So normally there would have been a horizontal asymptote at 0. Now it's down at negative 1. And I can draw my characteristic shape of my exponential function. But now I know that instead of going through 0, 1, as a intercept, it's going to go through 0, 0. Now, this would be perfect if it was just subtracted by 1. But notice I have that negative x. So now that's a reflection of this image over the y-axis. So then, so what I can do is I can take that image and reflect it. And so now it's looking something like this. So I know it still goes through 0, 0. And then I do want to have some values here. So the fact that x is negative, like you could put in like, so we know x and y. So I know 0, 0 works. Put like negative 1, because then the double negatives become positive. So 3 to the first minus 1, which is 2. So I know 1, 2 is on this particular graph. And then you could put a negative 2, which is 3 squared minus 1. So that is 8. So then there would be my 3 anchor points. Okay, so now the next one here, similar strategy, that plus 4. What I might do is, again, draw something that's 4 units up. So that way I can kind of get a new bearing of the new axes. So there's my y, and there's my x. Right, so I'm going to go up 4 units, 1, 2, 3, 4, and put a dotted line. And that dotted line, it's nice because actually, like that, like going up 4, because that's my asymptote. So I know like y equals 4, and then this negative is going to take our normal graph. Remember, which was it would have been this shape, right? And it's going to reflect it over that new pseudo x-axis. Or if you reflected first and then pushed up, it would have done the same thing. So let's go ahead and get what that image looks like. And so then it's coming along here, goes through there, and comes down. So I still know that point right there, when x is 0, so we're going to get comma 3. Because again, when you're evaluating this, that negative falls outside that. So it's like 2 to the 0, which is 1, make it negative, and then add 4. So we're getting 3. And then maybe I want to add 1. So 2 to the 1 is 2 times the negative 2 is, 2 to the 1 is 2, and make it negative. So it's negative 2 plus 4, which is 2. So I know that there's 1 comma 2. And then if you put in 2, you get 2 squared is 4, make it negative. So then it's 2 comma 0. So those are your like 3 anchor points. Okay, let's go ahead and look maybe at number 3, because when I see 1/2 to the x, I might immediately think, oh, I know there's no transformation, right? I know exactly how to graph this. It's it's just our normal exponential function. But then you got to be careful. It's actually not. Okay, it's not this. Because if you think about 1/2, you start taking powers of 1/2, that they get smaller and smaller and smaller over time. So this is really the same thing as 2 to the negative 1. That right? So this is 2 to the negative 1 to the x, which could be thought of as 2 to the negative x. So then I know that, okay, so here's my horizontal asymptote at y equals 0. So then my graph itself is going to be a reflection over the y-axis. So then there's my 0, 1, And then again, if you put in like a -1, you get a +2 as the outcome. And then if you put in -2, you get +4. Okay, so I like that. And maybe I'll do another one, maybe something like number 6 would be a good one, because it's, this e to the -x is just going to make our labels a little bit awkward, right? But the +2 is helpful. So I know it's going to shift up 2 at least. I'm not sure why I said helpful. It's good to notice, right? So 1, 2. So I know my new x-axis is up here, and then that also is going to become my horizontal asymptote. Oops, sorry. So we'll go here. So I know there's a horizontal asymptote at y equals 2. Now, again, thinking about our normal exponential function looks something like this. Okay, so one of these negatives is going to reflect it across the y-axis, and then this is going to reflect that below the x-axis. So it's going to look below the pseudo x-axis, right? So it's going to look something like that. So that's the image I'm after. So let me go ahead and erase that, and that. Just kind of going backwards. So I know the general shape with those 2 reflections. So it's hugging the asymptote, goes to the intercept, and goes straight down. Now, this point right here, it's still going to be, when you let x be 0, whether it's e to the 0 or not, e to the 0 is 1. And e to the 0 is 1. And then you have your -2 times 1 is -2 plus 2. So actually, because of this stretch, our intercepts actually at 0, 0. And then we could put in, let's say, like -1 if you want, because that would at least make it positive. So you get -2, at least that exponent, times e plus 2, which is some weird random decimal. So like that point right there, I'd say -1. You could say like -2e plus 2. And then when you put in -2, that's like e squared. So -2 times e squared plus 2. So you can still label points, but it's maybe not as intuitive. All right, -2 e squared plus 2. So again, I thought this first video would be good just to kind of go through just a couple problems. And then what I'll probably do is I'll post a second video that goes through a few more of these practice problems. So, just kind of going through and thinking about that process. Me talking about it probably takes longer than you to actually graph them. But sometimes hearing that and seeing that simultaneously is very helpful.